Good morning, class. We are looking at polar equations and graphs. So we're going to go with polar equations and graphs. Next, we're going to cover the complex plane de Moivre's theorem, and we finish it up with the vectors. The objectives of the section: identify and graph polar equations by converting to rectangular equations, test polar equations for symmetry, graph polar equations by plotting points, reminding everybody of basic trig identities on this page. The sum, difference, double angle, half angle formulas. And over here, the discussion of polar coordinates when we started, which a pair x comma y in a rectangular coordinate system is represented with a pair r comma theta. We have a pole and a polar axis. And to change from rectangular to polar and vice versa, we use the following formulas: x squared plus y squared equals r squared, tan theta is y over x is r cosine theta, y is r sine theta, and r comma theta is not unique. There are many different ways of representing it, in fact, infinitely many. So all you have to do, add 2k pi, where k is an integer, or sometimes they call it 2n pi, to that. If you want to change the r to negative r, just add pi or odd multiples of pi. Now, polar equations and graphs. Here's the rectangular grid. Here's a polar grid. A polar equation of a curve is the one expressed in polar coordinates and written with r as a function of theta. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. These equations may demonstrate different forms of symmetry around the axes. Let's look at this example. We want to identify and graph this equation, r equals 3. And reminding everybody that x equals r cosine theta, y equals r sine theta, x squared and y squared, they add up to r squared, tan theta is y over x. Since r squared is x squared plus y squared, what if we raise both sides to the second power? So square both sides, in which case the left side is x squared plus y squared, and the right side is 9. And that is a circle that we are familiar with. The radius is square root of 9 or 3, and it's centered at 0, 0. So with r being 3, it is a circle centered at 0, 0, or the pole. So it's a simple case. Recognition from the rectangular equation, we can easily graph this. Theta equals pi over 4. We want to identify and graph the equation of theta equals pi over 4 and convert it to a rectangular equation. So when we look at this, one of this will help us, and we know tan of theta is y over x. So let's take tangent of both sides. So when we do that, tan theta is y over x. And we know tan of pi over 4 to be 1. Therefore, the cross product will give us y equals x. And this is a line through the origin. So when theta is pi over 4, y equals x. So that would be the line. So just to recap this, I want to make sure that we understand what happened here so we can see the general format. So this makes y equals x times 1, which was the tan of that. So in general, when we have theta equals any angle, then y equals x times tangent of that angle. For example, if it's pi over 6, then y would be x times pi over 6. That's the concept. Whereas in the previous page, when r is a number, it's just a circle centered at 0, 0. R sine theta equals 2. Again, we are going to look at what we have here. We know that R sine theta is represented by y, so we can replace this with y. And we know this is a horizontal line. Therefore, R sine theta equals a number results in y equals that number, results in a horizontal line in general. Identify and graph the equation of r cosine theta equals -3. Convert to a rectangular equation. And again, we know all of this. And we notice r cosine theta is x. Therefore, we can replace that with x. X equals -3 is a vertical line. Therefore, r cosine theta equals any number results in x being equal to that number, giving us a vertical line. X equals -3. R cosine theta results in a vertical line when it's equal to a constant. Identify and graph this equation. R equals 4 sine theta. Convert to a rectangular equation. And as always, we have this. So in essence, we looked at this previously. And that is, the trick is to multiply both sides by r. So what do we get here? R squared. What do we get here? 4r sine theta. So r squared is x squared plus y squared. We're going to replace it. 4r sine theta. R sine theta is y, so it's 4 r sine theta. Therefore, it's 4y. And this we know how to handle. We're going to move the 4y to the left and put it next to y squared. We make up and complete the square here. This is b. B is -4. Divided by 2 is -2. Square it is +4. Let's add 4 to both sides. So this is x squared. And what is this one? Always b over 2, this variable, whatever it is, y, and b over 2, including the sign. So minus 2 quantity squared. Again, we recognize this as a circle centered at 0, 2. The radius is square root of 4 or 2. And let me write the general form, reminding everybody of x minus h quantity squared plus y minus k quantity squared equals r squared. That's what we are using. So we just draw a circle centered at 0, 2 along the y-axis, go up 2 tick marks, that's the radius, and come up with a circle. Okay. Identify and graph the equation. In this case is r equals negative 2 cosine theta. And we want to convert it to a rectangular equation. So far, we noticed that when r is involved with sine theta, that means r equals a number and sine theta, it ends up being a circle centered somewhere along the y-axis. Let's see what happens here. We're going to use the same trick, and we're going to multiply the r and negative 2 cosine theta by r. So this becomes r squared. This becomes negative 2 r cosine theta. So let's just write it. So this becomes r squared. And this becomes negative 2r cosine theta. Now, left side r squared, of course, is x squared plus y squared. Right? And r sine theta is y, r cosine theta is x. So this is minus 2, because it's r cosine theta, minus 2 r cosine theta, minus 2x. So again, r squared is replaced with x squared plus y squared, and r cosine theta with negative 2x. Again, we move everything to the left, and we're going to put this one next to x squared this time. In this case, b is 2, divided by 2 is 1, squared is 1. Add 1 to both sides. This is x plus 1 squared. The rest remain unchanged, which means this is a circle centered at negative 1, 0. The radius is the square root of 1, which is 1. So r equals negative 2 cosine theta, or x plus 1 quantity squared plus y squared equals 1, is a circle centered at negative 1, 0, r equals 1. So along the x-axis, go to the left by 1 tick mark, that's the center, and draw the circle. So when we have r equals a number times cosine theta, it appears to be a circle, but this time it's centered somewhere along the x-axis. So let's summarize what we've done so far and the graphs that we've come up with. R equals any number is a circle with its center at the pole with radius A. When we have R sine theta equals a number, becomes a line. When it's R cosine theta is a number equals a line, but R sine theta is a horizontal line. R cosine theta equals A is a vertical line. So R sine theta equals A is a horizontal line. R cosine theta equals A is a vertical line. When theta is a number, when theta is a constant, Y becomes tan of theta times X. So whatever that, let's say theta is pi over 4, so you put the pi over 4 here. That's what we mean, okay? So as it was mentioned, horizontal line, R sine theta, if it's equal A, so Y equals A, and R cosine theta equals A, X equals A. So those are the lines. What else? When, to make it easy, we are assuming A is positive. So R is 2A cosine theta, and again, 2 times that, so we can see that. All of this, 2A cosine theta, minus 2A cosine theta, 2A sine theta, minus 2A sine theta, all of them are circle, all of them. In this case, and in all of them, okay, the radius is half of this number, but in an absolute value, all of them are circle, all of them have radius equal to A. When it comes to cosine, the center is along the x-axis. In this case, A comma 0, in this case, minus A comma 0. When it comes to sine, the center is along the y-axis. So in this case, 0A, in this case, 0 negative A. You don't have to memorize it. It's fairly easy to do the conversion and graph. All right, the next topic we want to look at is the concept of a symmetry. We are familiar with symmetry in the case of a rectangular coordinate system. One may be symmetric with respect to the x-axis or the y-axis or the origin. With respect to the y-axis, we call it even. With respect to origin, we call it odd. Now we have similar situations in polar coordinates. Symmetry with respect to WRT, with respect to the polar axis, meaning in essence the x-axis. If in the polar equation, r comma theta can be replaced with r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So take a look at the graph. If we change r comma theta to r comma negative theta and they are equivalent, that's the concept. So you see the symmetry with respect to the x-axis, or better yet, we're going to call it polar axis here. Symmetric with respect to the line theta equals pi over 2 or y-axis. If in the polar equation of r comma theta, we replace it with r comma pi minus theta, then the graphic is symmetric with respect to the line theta equals pi over 2. So if we change theta to pi minus theta and gives you a point on the graph, that's the meaning of it. In this case, if you change the theta to minus theta and gives you a point in the graph, that's the meaning of it. Symmetric with respect to the pole or the origin, if in the polar equation r theta can be replaced with minus r theta, or r comma theta plus pi, then the graph is symmetric with respect to the pole. By the way, if it happened to be symmetric here and here, then it's symmetric with respect to the pole as well. So if it's symmetric with respect to polar axis and symmetric with with respect to the line theta equals pi over 2 makes this happen too. And so that's what it looks like. We're going to look at a couple of examples of that. So we'll see how that goes. For example, r equals 1 minus sine theta. We are going to try all of this. And we're going to start with the first one. If we change the theta to minus theta, do we get the same equation? Let's check it out. So 1 minus sine theta, I'm going to change the theta to negative theta. As you know, sine of minus theta is minus sine theta. And therefore, it's 1 plus sine theta, and they are not the same. So the first one fails. That means it is not symmetric with respect to the x-axis or polar axis. Let's see the second case by replacing the theta with pi minus theta. So 1 minus sine theta, we're going to change it to pi minus. How do we do that? We have to find what sine of pi minus theta. So that's sine pi cosine theta minus cosine pi sine theta. I hope you remember the identities. And so let's replace the sine pi with 0, cosine pi with negative 1. So this is plus sine theta and 1 minus sine theta. So we got the same thing. That means that works. That means the graph is symmetric with respect to theta equals pi over 2, in essence, if you can think of it as the y-axis. What about the last one? Let's replace the r with negative r and keep the right side intact. We're going to multiply both sides by negative to change this to r. So this becomes positive r, this becomes negative 1, this becomes plus sine theta, and they are not the same. This is plus. Okay, so that doesn't work. We have to. Let's try it this way. So this is sine theta cosine pi plus cosine theta sine pi. As you know, cosine pi is negative 1, sine pi is 0. So this goes to 0. This becomes minus sine theta with negative becomes 1 plus sine theta. Is it the same as that one? No. So not symmetric with respect to the pole. We want to graph this. Now, I'm going to have a couple of different approaches for that because I want you to see how it's done. First and foremost, if we want to plot points, I'm going to go with easy ones. For example, 0, pi over 6, pi over 4, meaning common arcs that I don't need to use a calculator. And r is 1 minus sine theta. So I'm going to go over a couple of them, and the rest of them I put up. 0. You know sine of 0 is 0, so this becomes 1. Pi over 6. You know sine of pi over 6 is 1/2. So in front of that, 1 minus 1/2 is 1/2. Pi over 4. 1 minus square root of 2 over 2. Pi over 3. 1 minus square root of 3 over 2. What about pi over 2? Sine is 1. 1 minus 1. This gives you 0. 5 pi over 6 is the same as pi over 6 because sine is positive in the second quadrant, 1/2. 1 minus 1/2 gives you 1/2, and I'm going to write the rest of them. So I don't want to go through the whole thing, but a couple of them I write in front of them. For example, this one is 1 minus sine 0. This one is 1 minus sine pi over 2. Okay, sine of pi over 2 is 1. This one, for example, I would write 1 minus sine of 11 pi over 6. As you know, in the fourth quadrant is the same as pi over 6, but it's negative. So it's 1 plus sine of pi over 6, which is 1/2. So 1 and 1/2 becomes 3/2. And we have this. So let me actually erase the mess. Now, these are the pairs. And when you want to put something on the grid, and I'm going to quickly graph a few points on that, you really want to start with theta, okay? So, and I'm going to go with easy ones. For example, this one, 1, 0, I'm going to go with theta. Theta means this, 0. And let's assume that actually this is 1. So this is 1/2, 1, 1.5, and 2, just to make it that easy. So I'm going to graph this one. And that is this point. Again, remember, a circle is like 1/2. Okay, so this is 1. So theta is 0, that's 1. If I want to go with, again, easy numbers, 1/2 and pi over 6 is somewhere here. Let's see how many we have. 1, 2, 3, 5. Okay, so somewhere here. Okay. Then I want to go with 0, pi over 2. Again, I want to go with the easy numbers. Along the y-axis is pi over 2. So pi over 2 is up here. But it's 0. So right here, it just goes like that. Again, this is not to scale, but just to give you an idea. I want to go for another easy one. 1 pi. Pi is on the other side. So this is pi, right? This point, believe it or not, looks like that. You can pick somewhere here, 7 pi over 6. Seven pi over 6 is somewhere here. And two, 3 pi over 2. So 3 pi over 2 is down here, right? And it's 2. Remember 1, 2, so it's here. So it looks like this one here. And then 1 and 2 pi back here again, this point. So it will look something like that. Now this is not obviously to scale, doesn't look that good, but roughly this is the shape. Okay. Now, of course, here's a better and more detailed graph, similar to what I have. So I'm going to clean up the mess so you can see the actual graph, which is more precise. So we have, again, easy points. Look at 1, 0. Here's 1/2 pi over 6. And here's 0 pi over 2. 0 power 2. Okay, 1 pi. Remember, first the pi and then 1. Okay, continue here. 2 and 3 power 2. Here. Go back. 1, 2 pi. Go back to 1, 0. It's the same thing. And as you can see, the graph is symmetric with respect to the line theta equals power 2, or in essence, the y-axis. There's a different method to graph this, and to do that, we graph the sine theta, and then we shift it up by 1 in a rectangular coordinate system, looking like that. R equals 1 plus sine theta in Cartesian coordinate system. And now we're going to read the values of R corresponding to increasing values of theta. So first we graph this. This is a rectangular coordinate system. As theta increases from 0 to power 2, there are 1, 2, 3, 4 arcs. You remember the 4 arcs? So the first arc is this part. So we go from 0 to power 2 as theta increases from 0 to power 2. At 0 is 1, or increases from 1 to 2. So as it increases from 0 to power 2, the R value goes from 1 to 2. So when theta is 0, R is 1. When theta is power 2, 1 plus 1 makes it 2. That's the concept. So take a look at the graph. At theta equals 0 is 1. At theta equals power 2 is 2. So it looks like that. It's not quite a circle. Now, the second part, maybe actually I graph this, so this part. Up to pi. So as theta increases from pi over 2 to pi, now we are going from here to here. Now we go down from 2 to 1. So from 2 to 1. And remember, this has location 1, comma pi. Now for this part, as we go from pi to 3 pi over 2, when we plug in pi, we get 1. When we get 3 pi over 2, we get -1, and 1 is 0. So it's 1 to 0. So it goes like that. So here's the 1 value, and it goes to 0. And finally, from 3 pi over 2 to 2 pi, we go from 0 to 1. This is the height, 0 to 1. And that's the final piece. Again, this is a different approach you can use, and that will do the job. A different approach. Do you have to do it both ways? No, but I wanted you to be exposed to both methods. We want to graph R equals 1 minus cosine theta, and again, we are going to pick the value of theta first. And we go with easy ones, for example. And by the way, this creates what is called a cardioid. So what we looked at in the previous page was an example of a cardioid. And we're going to look at another example. The previous one involved sine. So when it's in the form of a times 1 plus minus cosine theta or a times 1 plus minus sine theta, it gives you the shape that we've seen on the previous page, cardioid, and we're going to do the same thing here. Let's see how it looks like by picking easy points. For example, 0. If I pick 0 here, cosine of 0 is 1, 1 minus 1. Then let me just write this. Oh, I don't want to write the whole thing. 1 minus cosine theta. So if I put 0, I get 0. What if I put pi over 6? Cosine of pi over 6 is square root of 3 over 2. So 1 minus square root of 3, 2. Let's go with pi over 4. 1 minus square root of 2 over 2. Let's go with pi over 3. We know cosine of pi over 3 is 1/2. 1 minus that is 1/2. Pi over 2 cosine is 0. So 1 minus that is 1. 2 pi over 3, it's negative 1/2 because it's the same as cosine of pi over 3. In the second quadrant is negative. 1 minus negative 1/2 makes it positive 3/2. And at pi, you know cosine is negative 1. So negative 1 with negative becomes positive 1, and 1 becomes 2. So if we stick with those, just those, and I'm going to start with that. By the way, those are the pairs. So if we go with this pair, 0, 0, right? 1 pi over 2, this is easy. Let's say this is 1. And by the way, perhaps I need to go with pi over 3 with pi over 3 and 1/2. So somewhere here. This doesn't look that good, but you know, it gives you an idea. 2 pi, this is 2 pi. So it'll look like this. It'll look like that. This half looks like that. Of course, what you have here is with more details. Now, if I replace the theta with negative theta, you know cosine is an even function, so it's still the same. And what that means is that since we changed the theta to negative theta, it's symmetric with respect to the polar axis. It's symmetric with respect to the x-axis. So just by symmetry, we get the same thing here. If we stick with the symmetry. Or we can just go with more. For example, 4 pi over 3. Cosine of 4 pi over 3 is the same as pi over 3, but it's negative. So it's negative 1/2. 1 minus negative 1/2 gives us 3/2. 3 pi over 2 cosine is 0, so this gives you 1. 5 pi over 3 is the same as pi over 3, and it is positive because cosine is positive in the fourth quadrant. And so 1 minus positive 1/2 makes it 1/2, and 2 pi is the same as 0, makes it 1. 1 minus 1 is 0. And so plot those pairs. And you come up with this graph. So let me actually clean up mine. So as you can see, you could have used just the symmetry and that would be good enough. Or if you pick up a few more points, that will do the job. So again, in short, we noticed with a couple of graphs that when we have r equals a times 1 plus minus cosine theta or a times 1 plus minus sine theta, we end up with a cardioid shape, heart shape in essence. Now, it's different because these two numbers are not the same in an absolute value. If this was 2 or minus 2, this one would be like a cardioid. So what happens here, let's, again, for practice, look at the symmetry. Let us change the theta to negative theta. And as you know, cosine of minus theta is the same as cosine of theta. We get to the same thing, and therefore it is symmetric with respect to the polar axis, with respect to the x-axis. You can think of it, polar axis. Let's try pi minus theta here, pi minus theta here. We're going to expand this. So 3 plus 2 times this becomes cosine pi cosine theta plus sine pi sine theta. As you know, cosine pi is -1, sine pi is 0. Therefore, this goes away. This becomes -2 cosine theta. So r is 3 minus 2 cosine theta. Compare, are they the same? No, this test fails. Let's replace the r with -r. And that fails because you can take the negative sign to the other side, becomes -3 minus 2 cosine theta. So that fails. Let's try to change it to theta plus pi, and this will fail. I'm going to leave it for you to do what I did here. In other words, change this to cosine theta, cosine pi, minus sine theta, sine pi, and see what you get. You ultimately get to the same one, and this fails as well. So let's go graph this by picking up pairs. So we are continuing with the question, and we're gonna go with easy numbers again. In this case, we know that it's symmetric with respect to the polar axis, the x-axis. So if we have half of it, then the other half is the same. That's one concept. So let's look at a few points. For example, if I put 0, cosine 0 is 1. So this is 2 and 3, 5. So 0 gives me 5. Pi over 6, 3 plus 2 times square root of 3 over 2, which means 3 plus square root of 3. Pi over 3 is easy because cosine of pi over 3 is 1/2. 2 times that makes it 1, with 3 makes it 4. Pi over 2 makes it easy because cosine is 0, therefore it's just 3. 2 pi over 3 is the same as pi over 3, but it's negative. So this is 2 times negative 1/2, which makes it -1, and 3 is +2. And pi, cosine of pi is -1 times 2 is -2, with 3 becomes +1. So I'm assuming we can easily see those. So let's put a few of them again, easy ones. I don't want to put all of them. Let's okay, let's go with this one. So 1, 2, 3, 4. Let's assume this is 5, everybody, and it's not, because 1, 2, 3, 4. Let's assume it's 5, 0, 5. Pi over 3, 4 is something like this. Let's assume this is pi over 3, 4. pi over 2, I like this one that makes it easy, is 3. So this one, again, that's the assumption roughly. Pi gives us 1. So if you were to graph this, it'll look like that. And the other half, by symmetry, will do the job. Again, I highly recommend you go with the quadrantal angles. That means 0, pi over 2 pi, 3 pi over 2, 2 pi, and maybe a couple in between. That's all you have to do. Again, 0, pi over 2, pi, 3 pi over 2, back to 2 pi, maybe 1 or 2 in between. So again, let me clean up mine. So you see 5, 0, you see 3 pi over 2, 1 pi. This one is 3 and 3 pi over 2. Go back, and a couple of points in between, as I mentioned, will do the job. So as it appears, when it involves cosine, it's symmetric with respect, let's say x-axis, the polar axis. If it involves sine, with respect to the y-axis, or theta equals pi over 2. We're going to look at this one, and the name is lemma. We want to graph this. And before even we continue, as it appears, it involves cosine, so it should be symmetric with respect to the line x-axis, or better yet, polar axis. So let's again go with easy numbers such as 0, pi over 6, pi over 4, all the way to 2 pi. So I'm going to go over a couple of them. For example, 0. When I plug in 0, cosine becomes 1. 2 plus 3 is 5. Pi over 6. Cosine is square root of 3 over 2, so times 3 plus 2, and you can write that. If you want to graph it, you have to go with the decimal representation to make it possible. Pi over 4. So 2 plus 3 times cosine of pi over 4 is square root of 2 over 2. Pi over 3 is a nice one because it's 1/2. Cosine is 1/2. So 3 times that is 3 halves. 3 halves and 2, 7 halves. That makes it nice and easy. Pi over 2 cosine is 0. So it's just 2. Pi cosine is -1 times 3 is -3, with 2 is -1. So -1. 2 pi, the same as 0, gives you 5. So I've done most of it for you. So you really have to know your common arcs, and those are the pairs. I'm going to put a few of them there. Again, not necessarily to scale. For example, 5, 0, that means you go with the 0 angle. Let's assume this is 5 and it's not. So the easy one. I want to go to this one first. I just want to make a point that it's really not too bad. If you go to 2 pi over 2, it's somewhere here. Let me just go with those, and then if I want to pick something in between. So right away, that means we are going to go from one to the next, and if you need, you can pick another one. So What about this one? I want to make sure you understand what this means. Pi is this one. Positive one would be here, but negative one takes you back there. So I want to make sure you understand that. I'm going to use a different color on that. This one is like, again, this is not to scale, like this point. Let me go back to same color. Let me just use this one also. 2 pi over 3 and 1/2. So somewhere here. So if you were to just to stop there, that means it goes like that. And then you repeat that. Repeating means by the symmetry. Now, I want to explain something to everybody. So when you plot, this point is clear, this point is clear, this point is clear. I want to explain about this one. It goes through zero in essence. And the reason we don't have it here, it's not a common arc. So how do you know that? Set this equal to 0 and solve. Set this equal to 0 and solve. Cosine theta equals minus 2/3, and theta is cosine inverse of minus 2/3. Okay, so it goes back to that point. It has to. So again, why do we not have it here? Because it's not a common arc. So we have to, precise answer is that. So it goes to 0, and then here, and it goes to 0 again because this creates, remember, 2 angles between 0 and 2 pi. So if you want to know, you can solve this and it gives you this point. And remember, when r is 0, actually is with any angle, you end up with the pole. All right. Graphing polar equations, it's called a Rose graph, the equation of r equals 2 cosine 2 theta. Let's also examine this with symmetry by replacing theta with negative theta. As you can see, because it's cosine, it's even, and therefore it is the same as 2 cosine 2 theta, and it shows it's symmetric with respect to the, can call it x-axis if you want, polar axis. Let's change the theta to pi minus theta. So we change the theta to pi minus theta, which means now this is 2 pi minus 2 theta. And as you know, 2 pi or 2n pi gives you the same result because sine and cosine functions are periodic functions with the period of 2 pi. This gives you the same thing back, minus 2 theta, whatever this one is. And as you know, cosine of minus 2 theta is the same as cosine of 2 theta. So that is also working. So the graph is symmetric with respect to theta equals pi over 2. Because these two work, you don't even have to do the third one. with respect to the pole, because it's symmetric with respect to the polar axis, plus symmetric with respect to theta equals pi over 2, then it's symmetric with respect to the pole. So it works. So the symmetry is everywhere. Let's look at the graph. And again, I'm going to pick up some easy points. So let's go from 0 to pi over 2 only and see what we get. R equals 2 cosine 2 theta, plug in 0. That means cosine of 0 is 1 times 2, so that gives you 2. Let's plug in pi over 6. 2 of that is pi over 3. Cosine of that is 1/2. 2 times that. 2 times 1/2 is 1. Let's plug in pi over 4. 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. The product is 0. So pi over 4 gives you 0. So pi over 4 gives you 0. Pi over 3. If I plug in pi over 3 times 2 is 2 pi over 3. And 2 pi over 3 is the same as pi over 3, except it's negative for cosine. So it's negative 1/2. So 2 times negative 1/2 makes it negative 1. And if I put pi over 2 times 2 is pi, you know cosine of pi is negative 1 times 2, makes it negative 2. So I hope you can know this from what we have already done. So we have 0, 2 along the x-axis. Pi over 6 is 1, and at pi over 4 goes to 0. So take a look at what happens here. This one is 2, 0. When the theta is 0, we have 2 tick marks. Pi over 6, the distance of 1. And then at pi over 4 goes to 0. Just look at these 3 points. Never mind the rest, just 3 points. So we went back to 0, 0 in essence. Remember, 0, pi over 4, 0 with any angle, it really brings you to the pole. Now, negative 1, pi over 3. So remember, pi over 3 is here, somewhere here, right? And r is negative 1, you go in the negative direction. So please understand, pi is between 0 and pi over 2. So we are here, but 1 tick mark on the negative side. Pi over 2 is negative 2. So pi over 2 is here. So 1 and 2 tick marks, but down because it's negative. Okay, so take a look at this, what happens. And this will continue from pi over 2 to pi to 3 pi over 2. So if you go with pi over 2 to pi, and then pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. So it will take you there. It will take you there. It will take you there. Take a look. And this is exactly how it moves on. That's a rose. And it's a better graph. Let me again clean up the mess here. That's how it looks like. So it's moving in this direction. That's the direction it moves on. It is called a rose because it looks like that. And if you were to put the calculator in a polar mode, you see the graph, and I highly recommend if you have a calculator, try this. It shows as it's creating it, how it moves in the direction that I mentioned. Finally, I want to give you this definition. Rose curves are characterized by equation of the form r equals a cosine n theta, r equals a sine n theta, a can't be zero, and have graphs that are rose shaped. If n is not equal to 0, is even, the rose has 2 times n petals. If n is not equal to plus minus 1 is odd, the rose has n petals. So I want to go back to this. Because this was even, 2 times 2, it had 4 petals. Also, there are other graphs, and r squared equals a squared sine 2 theta, or r squared equals a squared cosine 2 theta. Those are also graphs that you deal with it in the case of a polar graphs. There are many graphs, but I think this is basically the main thing we need.